So we are answering the question saying make a one view assembly drawing of the universal joint. The scale is 2:1. Include an item list. So in the question we have the part 1, which is the fork. We have the part 2, the ring, and part 3 and part 4. Each of them we've been given the total number of parts of their quantity. The part 1 is 2, meaning that we're having 2 forks in the diagram. We have part 2, the ring, we only need 1. We have part 3, we have 2 of part 3 and 4 of part 4. The part 3 is the spring pin and the part 4 is the screw FH. So the question says we should make the drawing in 2:1, meaning that we're doubling up the measurements and the measurements are in inches. So to properly use them, we're going to be converting each measurement into millimeter. So starting our drawing, we'll be using our horizontal line and our vertical line. So our first measurement is first height of 50.8, approximately 51. And we're splitting that into 2, having 25.5. So at the end of the day, we're having 25.5, and a total of 50.1. And our next measurement is 26.2. Here, the inner diameter, so we're going to be measuring 13. So the next thing we have is circle. We have a circle in this point of diameter 12.7, which is approximately 13. So we'll be measuring 6.5 up and down. This. And then when doing that, what we just measured there is this length, this and this. So next we're going to be moving up to these two diameters here. We have diameter 0.28 and diameter 0.5, which is converted to be 14.2 and 26. So diameter 14.2, that's diameter 7. That's radius 7, so measuring 7. So
from the midpoint.
From the midpoint here, measure 7 and 7 here. So at the end of the day, it's going to little bit go just a little bit more than the past
Wait, that's not what it is.
measurement. Okay. Yeah, thanks. Yeah. And yeah. So it's a little more than it. And the next one is next we have a diameter of 25.4, approximately 25. So we'll be measuring 12.5 at both ends, which is here and here. So If you have this and this. So, with that being done, that means we measured out everything here. So we're moving to our horizontal measurement. The first measurement we're having is 20.3. We have 20.3 and 40.6. So 40.6 is approximately 41, and at 20.3 you can make it 20.5. So project the two. First. Second. And our next measurement is to this center, which is 31.5. So measuring 31.5, sorry, 31.5 meters. Measuring that. Forget that. So then next we have a thickness here, which is calculated to be 12.7 from this point. So measuring 13. Remember, all the measurements has been converted and increased to the scale of 2:1. So next we'll be taking making this arc, the semicircle here. Since we don't have measurements, we just put our compass on the center, extend it to the end. Okay. Draw the curve. And that's being done. Measure 12.5 for first curve. And construct it. So for the inner one, we're not going to be constructing the inner one, because you should remember it's in this place our screw is going to be in. If you look at the side, the front view, it shows that this shaping is for a screw. So if we're going to be inserting our screw in the assembly, the inner diameter will not be shown, but we're still going to need the measurement, so we'll leave it. So the only thing we can do is, for our measurement on the vertical, we pick up the length of our screw and just pinpoint at both sides. So when we want to construct it in the front view part, you'll be able to easily do so. And then the same with the outer one too. It will be extended well. So that's been done. Using any one, whether you're 45 by 45 or you're 60 by 30, you draw a straight line, an inclined line, a little one. Measure at both ends 0.1. So you have 0.1, 0.1. Then construct a line to form the screw head. So with that, you've represented the screw. Moving on, constructing this side. So basically the direction. And below. And above. So at this point, the inner diameter here of what's the diameter again? So the diameter of 13, meaning we're measuring 6.5 to measurement of 6.5, having the center, so having a circle here. The next step, the hidden details here should be like represented with hidden line as your so with the hidden details being put, the next thing to do is put the other side of the fork. We should remember the fork is something that interlocks. So one comes in the front, the top view side, the other one comes in the front view. It look more or less like inverting this to fit into this. So we're going to be starting our measurement from here. Since we have this point, centrifying to this point for the screw, so take our measurement from that point, which is 25.4. So measuring 25.4 from here, which is approximately 25. So and that will be projected. So you can also, to make it more easier, project the center. So with the measurements, the first measurement we did here was for the two screws. So the distance from here to here, remember we're doing it in inverse, from here to here, that is 31.5. So I'm going to measure 31.5. And project it. Then next we're measuring this thickness of 13 inside. And you should remember it's interlocking, so since it's interlocking, there should be some point of contact, more or less like an overlap. So the moment you're having this overlap, you should know that is normal. And next, our next measurement is this back, which is a distance of 40.6, which is approximately 41. And we have 20.5. So remembering the fact that this diameter here is diameter 13, and the same thing here, so we're going to measure 6.5, 6.5. Mm-hmm. 6.5, 6.5. So, and same thing here, measuring this thickness of 13. Before we can measure the 13, we've been given a distance of 1.12 here, which is converted to be 57. So measuring 28.5 up and down from this center line. So on this center we measure 28.5 and 57. So after taking a measurement of 28.5, 28.5 to distance, next thing we'll be measuring is the thickness. Yeah, from the question we've been told that we have a thickness here of 0.25, which is converted to be 13. So we're measuring 13 both points. So we have your 13 here, and here also building 13 here also. And at this point we projecting our lines first.
There's no way I can continue with that video.
So, with the two being projected, we can now outline the points at which we need to outline. We should remember we have a curve here, a curved edge, even though we're not given a radius, since the thickness here is 13 and here is also 13. We'll just be using the natural radius of 13. So meaning put our compass at the edge where the two inner points intersect. So our compass there. So making this point board. Making this point board. The upper part board. So we see that the edge there. The next, this point. So
Is that what you say? I'll be flexing.
So this point will be bolded. And then this point. This. This. So it is being done. The back will be bolded. So this will be this point. Remember our measurement is 40.6 down here, and we have 20.3, which was approximated to 41 and 20.5. So making this point bold. Then next, the hidden detail on this point. So complete this point, and then complete this point. And with that being done, next is for us to show the point at which our string pin would come in. Next, our ring. Our ring is of the same height with this. The ring total height is 50.8, which is approximately 51, but it has a thickness of 31.5. So since it has a thickness of 31.5, we'll be using 32, so we'll measure 16, 16. So this point, and then this point. With that being done, okay. So next, at this point, to be closed off. So this point to be closed up. Then we also closed up. Yeah. So we have the ring at this point. Yeah. And then our projection for our screw here. For the screw, we'll be using our 45 degrees. Since we're not giving an angle here or a distance for the screw, we're going to be using 45 degree at these two ends. So using 45 degree. Currently I don't have a 45 degree, but to create a 45 degree here, all I have to do is at this point of the inner diameter, I put the compass there, Extend it to the outer diameter. Then duplicate the measurement down. Do the same thing on the other side. So, then press it down. So, that measurement transfer to the other end at both sides, and that becomes your point. Yes, remember we're using feeding length for the detailing. So which is represented as feeding length. So complete it. So for the threading of the screw, measuring 2 at both ends. Two at both ends and a height of 2. So that means keeping a distance here. Of 2. So the 2 in here is for the threading, but the outer threading has a stop here, and the stop which we can represent with our set square. We can use a 30 degrees at this point just to create the break. So using our 30 degrees, at this point also, and here have our outer part of our screw. Every screw has a standard representation. So this is the representation of the screw FH. Then close it at the point of the circumference. Using 30 degree again at both ends. Give it closure. And same to me. So, with that being done, we've presented a screw at both ends. So moving on, we have to put a pipe. The universal joint is connecting, it's like more or less like a connector for 2 ends of a pipe. So since we're connecting 2 pipe, we have to put a pipe here and a pipe here with continuity. So doing that using the same diameter, we would extend the 2 points out. So at any given distance, so usually a distance of using 2.5, using the distance of 2.5 and extending the center line, we constructing the symbol of continuity. And to construct the symbol of continuity, it can be easily done by finding the center point of the both ends. Measure and find the center point. At those points, extend the line. Using your compass with any radius, put it on the line and extend to one of the ends. Hopefully that is going to meet the other end at the same point. So draw the arc. Do the same at the other end. This can also be represented with your circle template. It's quite easier when you're using a circle template. But in case you don't have access to a circle template, you can do it with your compass. And then close, close. And by doing this, put a section mark. Yeah. In here, you measure a distance of, at this point, you measure a distance of 3 2 times, that is 0.3. Another 0.3. There. Extend the dot. Extend the first. Extend the next. Then at any angle, incline them. And close as for that. And the same thing, and the same thing you've done here, you duplicate at this end. So with that being done, the next thing is show it through for the pin. So with this being done, the only thing needed to be done is representation of each part with part numbers. So using your 60-degree, you label out each part. and then represent them by their part numbers. You have part 1, then you have your part 2, square fish is your part 4, and your pin is your part 3. And with these part numbers, you can have a successful bill of material.